Hello, and welcome to Combinations. My name is Tuesday Johnson. Here's an introduction to concept with applications. Let's talk about the definition of what a combination is. A combination of n items taken r at a time is an unordered set of r items chosen from n. So you know how when you're running out of food, you have to go make a grocery list? Order doesn't matter, right? You just have to write down everything that you need first. You might put it in order at the store later, but for now we just need a listing of everything we need. I also think of this as like a grab bag, right? I can't see through the bag. I just need some. It doesn't matter the order. I need some groupings or handfuls of things. Keep in mind, permutations are ordered lists of items. Order matters. Order matters. First, second, third, a chair, an assistant chair, a secretary. Order matters. Combinations are unordered sets. Order does not matter. I like to think using the first letters. Permutations are particular because order matters. Combinations are chaos because order does not matter. Whatever helps you remember is the best way to do so. Let's look at some notations in the formula for it. The number of combinations of n items taken r at a time is given by the formula C of n comma r. This is very similar to the permutations formula. C for combinations, so if it's unordered, combinations. If it's ordered, permutations. The n is always the number of items we have, our total, and r is the number that we want. So we'll have n factorial over n minus r in parentheses factorial times r factorial. And this formula should be kind of recognizable. It's really just the permutations formula in which we've divided by r factorial, right? We've just taken out all the repetitions. Right, that's all it is. It's saying, yeah, 1, 2, 3 is the same as 3, 2, 1, so we'll take out all those same groupings of 1, 2, and 3. So let's look at an example. The Department of Mathematical Sciences needs a small committee to represent them for group pictures with the provost. If 9 people are willing to volunteer, it's a good day at the math department, but they only want 3 people from each department, or else, we'd be overwhelmed with probably biology people in the picture. Not gonna lie. How many different groups could the department send? Well, group pictures do not require order. Just all gonna be in the picture. We have 9 people. We want 3. We'll find the combinations of having 9, wanting 3, that is 9 factorial over 9 minus 3 factorial times 3 factorial. Remember the exclamation mark, that factorial does not distribute. You have to simplify inside the parentheses to get your 6 factorial first. Also, this is not the same as 18 factorial. Write them both down. You can see a huge difference. Use a calculator probably. So you have to take care of 6 factorial first, but remember this 9 factorial over 6 factorial, that leaves us with 987. Now we just divide by the 3 factorial, 3 times 2 times 1, and we'll have a total of 84. Alright, just like we did permutations before, we can simplify that portion for our combinations and then divide by all of our repeats. There are 84 different groups the math department could send to the provost, but we would probably first 3 to show up. I'm just saying, we don't actually calculate this kind of stuff all the time, except for fun. Alright, second example. In order to determine qualifiers for the final races in track and field, many times they will run heats. So maybe you have 40 different athletes and you'll run 5 heats of 8 athletes in each race, and the top 2 from each of those will go into the finals or some semifinals, or they'll work it like that. So if there are 8 athletes in the first heat and only the top 2 qualify for the next round, how many combinations of finishers are there? Well, we have 8. We want 2. It's not first and second. It's just the top 2. So we'll use combinations where we have 8, we want 2, filling in the formula 8 factorial over 8 minus 2 factorial times 2 factorial. When I do the division, I always use the biggest number, right? 6. So I'll write out 8 and I'll stop right before 6. 8 times 7 times, the 6 and everything else gets canceled out, and then I'll write down the 2 times 1. So 56 divided by 2 is 28 different ways 8 athletes can finish in a top 2 type of race. That's why they run it. Alright, I would love to have put in a sentence here, but it looks like yet again I forgot, and I know that students are frequently better than professors, so I expect you to still hit that sentence notation there. Thank you for watching this. I do have a video, permutations and combination applications together, so we can kind of see them comparatively and know which one to use and when. Thank you for watching.